Right there, this is exercise 6F, actually 6F.1, because there's two versions of this. And 6F.1 starts looking at integrating the hyperbolic functions, and we've got a second one, 6F.2, which will take it further. Now, just a reminder, please, about the graphs of cos x, sin x, and tan x, because these graphs are important. I want you to learn them. Also learn, please, the reciprocal functions. So if I do 1 over sin, you should remember that's called cosesh x. I can do a similar trick with 1 over cos, and that's called sesh x. And the last one is what that 1 over tan is called coth. They will be useful, and you'll definitely need those today. You'll also need these. These are three identities which are very much linked to the trigonometric identities. So cos squared minus sin squared is 1. 1 minus tan squared is sesh squared. This one is less used, but who knows, you might need it. And likewise, sometimes we're asked to find the inverse of a hyperbolic function, like so it might be the inverse sine of some number, and you can find that exactly using logarithms. So just be aware of that, and also perhaps also make note of this, because even though we don't get told what tan, for instance, differentiates to, you'll notice on our formula book, I mentioned this last time, you don't get given very much at all, but it does tell me that tan becomes sec squared. You can ignore the k's. Tan becomes therefore sesh squared, and you can see a direct analogy between that and this. And likewise, a sec, I can therefore write sesh, and that therefore becomes sesh x tan x. So just be aware of the fact that these answers, and all these answers too, you can be using them elsewhere. Find the maximum value of f of x equals sin over cos squared. On the face of it, this looks like, well, the fact that it says maximum value makes me think I need to do dy by dx. I need to set it equal to 0. Or in this case, I suppose f dash x is 0. And the fact that it says sin over cos, this sounds to me to be like the quotient rule. And the quotient rule says you differentiate one, you might remember it saying v du by dx minus u dv by dx. And that's what it gives you. So let's do that here. I'll set my u equal to sin, and therefore du by dx equals cos. Great thing about sin and cos, they just switch between the two. And then v is the bottom one, which is cos squared. Now using the chain rule, I can differentiate that quite easy. dv by dx becomes, well, it becomes 2 cos x, effectively to the power 1, but then times by the differential of cos, which is sin. So okay, let's do this then. So if I multiply these together, the diagonals, you should remember that it's cos squared du by dx, cos squared times cos, oh actually it's cos cubed x, minus, well it's this one times by each other, so 2 cos x sin squared x, all divided by the v. What was v? It was cos squared x squared, and that equals 0, because that's what we've said it equals up here. So what's that going to give me? It's going to give me, where's my pen? There it is. Oh, right, first of all, when you move that over, that times 0 is 0. So I can effectively ignore that, and I can also take out cos x as a common factor. Cos appears twice, so I can write therefore cos squared minus 2 sin squared. And I suppose this is crying out for me to change one of these two. Now I saw before that cos squared minus sin squared, that's a sin, equals 1. So it kind of implies to me, let's get rid of, which one should I get rid of? Makes no odds really. I can get rid of either. I'm going to move the that over there. I'm going to write cos squared is 1 plus sine squared. So I'll bear that in mind. It becomes cos x. Cos squared is 1 plus sine squared minus 2 sine squared. Which gives me either cos x is equal to 0, or if I tidy this up, 1 minus sine squared x equals 0, sine squared equals 1. So there's my two potential answers. Now if you just cast your mind back to this, so I can find the inverse sine of x using this formula. So log of that, log of x 1 plus x squared, all square rooted. So the x therefore, oh, first of all I've got to find sine x. Nearly made a mistake. Sine x is therefore equal to plus or minus 1 when I square root the 1. And sine x, x therefore is the inverse sine of 1. Which using that formula, as I say, we're going to use this here. It's 1 plus the square root of 2. It's log of 1 plus root 2. And over here we've got cos x of 0. Go back to here. If we put 0 here and 0 here, oh, it's a square root of minus 1. That sounds like no solutions to me. So let's see what I've got here. Oh, have I got a second answer? Let's see. I don't know. So what have we got? These are the posh answers, done slightly in a different way actually. 1 plus root 2 and f of x equals, oh, we wanted it, all right, so that is the only answer, which is what I got, and it also wants the maximum value of f of x. So what you're meant to do is substitute this, it's easy, quite easily done on your calculator, back into this function, type this in with 1 plus root, log of 1 plus root 2, and apparently it's equal to a half. There you go, I'll take your word for it. So a little bit of A-level maths work. So just a reminder, I've mentioned these already. We've got these three identities, so I've highlighted the fact that we've got equivalences before. But there's also these as well. So cos squared is the half of 1 plus cos 2x. Sine squared is half of 1 minus cos 2x. And tan squared is sec squared minus 1. They have their own sort of equivalents. So we'll come on to that in a moment. Simple integrations, I suppose. If I am asked to integrate cos of 2x, we should by now know it's a half of the sine of 2x. Don't forget your constant. And this one, therefore, by definition, becomes, I'll write underneath so we don't, this becomes a fifth of the cos of 5x plus a constant. We've got to be a little bit careful with sine and cos. Sine, cos, minus sine, minus cos. If I do sine, it becomes minus cos when I go upwards. So I reckon it's minus a fifth of cos of 5x plus c. And we also need to be able to deal with how to integrate trig functions. Now, again, this is really normal maths, but we've seen it now a few times. Cos squared, the trick is to write it as a half of 1 plus cos 2x. It's this bit. And then you can go, oh, well, that becomes x, and this, well, we've already seen what that becomes. And then you divide both parts by 2. Now, I know some people who learn this rule and almost just learn this. They learn that if you integrate cos squared, it becomes a half x plus a quarter sine 2x. Some people prefer it that way. Learn it by all means. And because of the only difference between this and this is a minus sign, this is exactly the same, just with a minus sign in between. Might be worth your while to learn these off by heart. And just note the lack of formulae in the new formula book. The old days, they gave us all these. Now they don't give us very much at all. So if I'm asked to integrate sine squared, cos squared, then here's an example. Cos squared equals that. Sine squared equals that. And if I'm going to do this example, so I'm going to rewrite this as a sine squared as this. Cos becomes sine. The 2 comes onto the bottom. So we're going to get a quarter of sine 2x. That becomes x, so it's minus a half x because of the half at the front plus constant. So again, this might be worth your while just to learn it off by heart. And integrating tan squared, well, we've already seen a bit of a trick in the past with this. But I'm just going to just highlight in your mind again that tan squared is 1 minus sesh squared. And the reason why I say that is because if I go to integrate tan squared, I write it like this. And you might recall that if you integrate sesh squared, you get tan. And I suppose I know that because we've said before, if I differentiate tan, you get sesh squared. That's how we started the lesson. So really all I've done is I've reversed this. And I'm saying if you start by integrating sesh squared, you get tan backward. So that's interesting. That notice then I'm trying to integrate tan squared. I make it into sesh squared, and the answer, because 1 becomes x and sesh squared becomes tan, the answer of the integral of tan squared is something to do with tan. I think I like the symmetry of that. But anyway, I have to put 1 and 0 into this. So 1 gives me 1. You can easily type in tan of 1 on your calculator. And if you put 0 in and tan of 0 in, tan of 0 is actually 0. So that's why I've not bothered with that. So, but if I type in tan of 1, so you have to press option on this, hyperbolic, tan 3 of 1 equal, oh, apart from I've typed in 0 then, I get 0.761. So that's not very nice, but that's as good as it gets. So interesting that I've just called it quits there. Well, my answer, again, it's 1 minus 0.762. So I suppose the answer is 0.238 if you want a decimal answer. But obviously when I did this first time, I was happiest with 1 minus tan of 1, which doesn't seem very satisfactory. The answers, the questions I want you to do then are just a few questions from exercise 6F. Don't kill yourself on them. Do a few, see what you can do. If you get to questions that are a bit confusing, just ignore them, miss them out, because there's another lesson coming tomorrow, which will be 6F as well, and hopefully the 2 bits will tie together and then it'll make more sense. So if that makes a little bit of sense, have a go. Otherwise, have a listen again. So best of luck.